Hi, welcome back again to the fourth lecture of motion. Yeah, now we got the notification, so we started early. So in last lectures we discussed about many things, right? So we have done distance, we have done displacement, we have done uniform motion, non-uniform motion, right? We also discussed about velocity, average velocity, speed and acceleration. Now in the fourth lecture that we're going to cover today, the dynamics will change, right? Usually in class 9th in physics, we often focus on the theoretical part. But what happens, like in this particular chapter motion, there are certain things which involves numerical. Like the most of the portion in this chapter is based on numericals, because anyways we will be discussing about the equations of motion. So from this lecture, the dynamics of motion will change. We have done the numericals, we have like discussed so many things, but initially it was like last three lectures were more of a basic, they were setting up we were setting up the basics to understand this numerical portion. So I would request you guys to really focus on, like from now on to this lecture, because anyways it will have lots of numericals. Also we'll be discussing the graphical part, right? We'll discuss the equation of motion numerically or by the algebraic method, but we also going to derive the equations of motion graphically. So it is very important for a 9th class student to understand that these are the basics that will help you in class 10th and 11th. So coming to the fourth lecture, we need to realize that it will be more of a numerical part and less of the theoretical part. Okay, so let's continue. Right, so what we're going to discuss today is the basic concepts of graph, right, and distance time graph, velocity time graph, what information we'll gather from the distance time graph and displacement time graph, what information we'll gather from velocity time graph. So there are certain things which becomes very important in this lecture. Okay, so starting with, obviously everybody knows about the graph paper, right? So this is x-axis and y-axis. Now it is very important to understand that what do we put on the x-axis. Like suppose if I talk about like two quantities here, obviously distance or displacement needs to be compared with some or the other thing, like its time, right? So remember, always on the x-axis we put the independent quantity. Now what is independent quantity? Distance is changing over time, like somehow distance is depending on time. Okay, it can depend on time, like with time distance can increase, but with distance it is not necessary that time will increase. So you're getting my point. So the thing is, the idea is that whenever we draw the graph now, we take two axes, x-axis and the y-axis, right? So on the x-axis there is always, remember, it's an independent quantity, and for the y-axis we can put the dependent one. So when I say distance time graph, on the x-axis I'll always plot time. Remember, I'll always plot time. Okay, and here in the y-axis I can change distance or I can change it to displacement depending upon the requirement, right? And velocity. So it can either be distance time graph, displacement time graph, velocity time graph. Okay, lots of comments. Let me just check. Hello. Okay, 9th May. Okay, great. Okay. Anyways. So on the x-axis, we'll put distance or displacement or velocity. So anyways, we're going to focus on distance time graph, displacement time graph, velocity time graph, right? So I already told you that on the x-axis, we'll be putting the independent quantity, right? Independent variable on x and dependent variable on the y-axis. So let's start. Two variables here are distance and time, right? So distance will be coming on the y-axis and time will be coming on the x-axis. Okay, let's move ahead of this. Now, I have drawn a table here. You can see that with time, like at time t is equal to 0, the distance is 0 here. Okay, at time t is equal to 5 seconds, the distance is 7 meters. Then at time t is equal to 10 seconds, distance is 14 meters. So with time, basically what is happening, that distance is increasing, right? तो अभी हो क्या रहा है यहाँ पे? अगर मुझे, like if I want to draw the graph for distance and time, if I want to draw the graph for distance and time, this is how it will be. So because both the things here, if you take a close look, distance is also positive and time is also positive. So we are taking just the first quadrant of the graph here, like not the whole. So we have taken the first quadrant because y-axis is also positive and x-axis is also positive. So if I start plotting, so at 0, it will be 0, right? So on the y-axis, I have put the distance 7, 14, 21, 35, 28 like this. And on the x-axis, I have given the time here, right? 5, 10, 15, 20, 25. Okay. So at time t is equal to 0, the distance is 0. So this is the point, right? 0, 0. Okay. Then at 5 seconds, the distance is 7 meters. So 5, 7. Okay. So these are basically the coordinates, right? Abscissa and ordinate. So these are basically the coordinates 5, 7. 5 is the time here and 7 is the distance. Okay, then the next point I'll plot, that is 10, 14. Okay, again 10 is on the x-axis, so it is time, and 14 is the distance coming on the y-axis, right? Then again 15, 21, similarly 20, 28, similarly 25, 35. Okay, so if you take all the points here, right? All the points, all the coordinates here, and if you connect them, you will see that you will get a straight line, right? Now what does this straight line represents? If, see, first of all, let me tell you, this straight line, right, and it has some slope, right? It is making some angle with the x-axis, say angle theta, right? It is making some angle with the x-axis. So this represents basically that, you know, the particle is in motion. First of all, this is the theoretical part, that for every second or for every 5 seconds, it is covering some distance, right? So if it is covering some distance, that means it represents that the particle is in motion. Otherwise, we would have got some different graph. That graph I can show you. It would be like this. Only the time is increasing, distance is not changing. Suppose, okay, suppose this is 30 meters. So with time, the distance is not changing. It is what exactly is changing? Just the time. So if the distance wasn't changing with time, then we could have easily said that, okay, the body is at rest. But if you take a close look here, for every 5 seconds, we are getting the new distance, right? If we are getting the new distance, that means the particle is in motion. So we need to understand, in some school level, they give you the two graphs. One is distance is parallel, like it is parallel to the x-axis. So if it is parallel to the x-axis, then you can realize that with time, distance is not changing. So if time distance is not changing, that means the particle is at rest. But here, with time, the particle is covering some distance, right? At 0 second, it was 0 meter, and then at 5 seconds it was 7 meter, then at 10 seconds it was 14 meter, then at 15 seconds it was 21 meter, then at 20 seconds it was 28 meter, and then it was continuously changing. So for every new time interval we were getting new distance. So we can easily say that yes, particle is in motion. So this is the first thing that we got from a distance time graph. Okay, that we can check whether the particle is in motion or not. Now, let's take a look. So let's make a triangle here. So this is triangle ABC, right? This is triangle ABC. This is the angle theta. This is the slope. Okay, this is the slope. So basically, like I can solve this using trigonometry, but if we don't know about the trigonometry, let me just solve with the trigonometry first. So tan theta, like if I write down for tan theta, it will be perpendicular by base. But if any of you have not, still not studied this trigonometric part, then you can simply say that, okay, AB is equal to AB. Okay, it can be written like this, that BC upon AC. Okay, but usually I follow this part, tan theta is equal to perpendicular by base. It becomes very easy to understand. So I would suggest and recommend that you can remember this part, that tan theta is equal to perpendicular by base, and then tan theta is what? Basically the slope. Okay, slope of this graph. So tan theta is basically what? Slope of this graph. Because if we remember this now, with tan theta we can gather so many informations, right? So tan theta is equal to perpendicular by base. So now we can easily check, because for every point theta is constant. Like if you take this point, theta is still constant. If you take this point, theta is still constant. If you take some other point, theta is still constant, right? So for every point or for every coordinate, theta remains same. So we can easily find out, like if I want on the perpendicular, I have the distance. On the base, we have the time, right? So if I say that tan theta is, suppose for this point I want to find out. So you have the perpendicular 7 and the base is 5. So coming is 7 by 5. Okay, so tan theta is 7 by 5. But also remember that there was one quantity, we call it as speed. Speed is equal to distance upon time. Remember, we have discussed in the last lectures. Speed is equal to distance upon time. So if tan theta is coming out to be distance upon time, I mean perpendicular by base, where perpendicular is distance and base is time. So tan theta is basically giving you the speed. Okay, so we can easily write down here that slope. What is tan theta? It is the slope of the graph. And what exactly do we have in the graph? Distance and time, right? So slope of this graph, which is equal to what? Tan theta, which is positive. The slope of the graph will give you speed, because tan theta is equal to perpendicular by base. Remember this. For now, even if you haven't studied trigonometry, you can still remember that tan theta is equal to perpendicular by base. I'm sure that you must have studied this Pythagoras theorem. H square is equal to p square plus b square, right? So you have studied this, h square is equal to p square plus b square. So using this only, with the help of this Pythagoras theorem and with the help of trigonometric ratios, remember, this is the Pythagoras theorem, right? So sometimes we need this, so we can write down in the notes, h square is equal to p square plus b square. So using the Pythagoras theorem and the trigonometric ratio. So what trigonometric ratio is required here? Tan theta. What is tan theta? Tan theta is perpendicular by base. Simple. No rocket science, nothing. There is nothing tough in this that you cannot remember. Just remember this small formula. Tan theta is equal to perpendicular by base. That's it. Okay? Because even if like this is the distance time graph, then we'll study about the displacement time graph, then we'll study about the velocity time graph. So in every graph you have to go through the tan theta only. Like you have to check that whether theta is constant, you have to check that theta is varying. So easily you can realize that okay, if theta is constant, that means it is uniform, something is uniform. It can be uniform velocity, it can be uniform speed, it can be uniform acceleration. So I'm exactly telling you why you need, trigonometric ratio. Right. So you need to remember that why this tan theta is equal to perpendicular by base. Why tan theta is equal to perpendicular by base. Why we are using this. Okay. So speed is equal to distance upon time. Speed is equal to distance upon time. Is it clear? Now, what exactly are we getting from this distance time graph? Slope of distance time graph will give you speed. Slope of distance time graph will give you speed. Slope of distance time graph will give you speed. Okay. So speed can be uniform or non-uniform. How we will check that speed is uniform or non-uniform? One thing that you need to understand is that you can simply check by checking the angle. Just check the angle. If angle is constant, then we can simply say that okay, speed is constant here. But if angle is continuously changing, we can say that speed is variable, right? Okay. Right. So there are certain comments coming. Equation of trajectory, बेटा यहाँ पे equation of trajectory की अभी जरूरत पड़ेगी नहीं आपको, ठीक है? This is very basic. So equation of trajectory अभी जरूरत है नहीं. Secondly, class 11 Newton laws of motion. Okay, बेटा. Now, like this is the class 9th topic, right? Class 11th की series, there is a different playlist on YouTube. Okay, so in that, whenever we will be discussing motion in a plane, there I will explain, the equation of trajectory. And once we are done with the, like right now, I'm sure that we are discussing unit and dimension. Okay, post that I'll be discussing vectors, and with vectors I'll be discussing motion in 1D and 2D. So it will take some time, but eventually we'll be discussing equation of trajectory and yes, NLM. Perfect. Like so much, but like it's my personal choice to teach NLM. It's so interesting, but you guys still have to wait for some time. Okay. So for now, I can only say that, this is also very important topic. So if you can focus on this, right. Yes, I am sure that you guys have doubt range maximum kab hota hai. Range is, it is maximum at theta is equal to 45. But these answers I'll be discussing in the class 11th playlist. This is class 9th. I'm sure that you guys are very interested, but still you have to wait till tomorrow, right? When we'll be discussing the class 11th topics. Okay. So I'll continue with this. Here you can simply analyze that whether the speed or velocity or acceleration is uniform or not by just checking the angle. So if the angle is constant, right? If tan theta is constant, speed is also constant, right? Or we can say speed is uniform. So remember, you need to write 2-3 points here. That first of all, the slope of distance time graph. Slope of distance time graph will give you speed. Also, the speed will be uniform or non-uniform. It will depend It will depend on what? The angle, right? If the angle is constant, then you will get the uniform speed. If the angle is variable, then you will get the non-uniform speed. Maybe increasing, maybe decreasing, that can, change. Okay. I hope this is understood well. Now, coming to the next, let's draw. This was like we discussed about the distance time graph. Now we'll be discussing about the velocity also and distance time graph for non-uniform motion. Like this was for the uniform motion, right? Find the velocity of the object in given graph. So this is the distance time graph, right? The last graph. So here 5/7 is the speed. Again here, 7/5. Right? It is 7/5. Then again here it is 14/10, which is equal to 7/5. Okay. Then it is 21/15, again 7/5. 28/20, so again it is 7/5. Okay. Then 35/25, again it is 7/5. So you can simply check that every coordinate you are getting the same speed, right? Okay, same comments so many times. No, beta. Actually, what happens, like when we are coming to YouTube, it is not, I personally think about this, that we shouldn't be, like I personally don't want to be limited for class 11th and 12th, right? So simultaneously, what we are planning is that we are going with 9th and 11th first, because it somehow it helps for the children who are preparing for sometimes for foundations, or they want to get a better note on the academics part. So like we have started with 9th and 11th, and eventually we'll be coming for 10th and 12th also. Okay. It's fine that sometimes what happens, this topics are equally important, because what I feel that when I start teaching class 11th, so I realize that there are certain students whose 9th basic were not clear, right? So I personally think that once the basic of class 9th are clear, and then definitely we can focus on the next level or the next classes, right? So don't worry. Anyways, yes, definitely. The main, see, it's just one person. So the focus is 9th, 10th, 11th, 12th, NEET, JEE Mains, JEE Advanced. Everything is on the focus, but eventually it will take certain time to just get a grip on it. Definitely, right? So I'll continue with this. Otherwise, right? So here what we can see is that we are constantly getting the same speed. So I simply told you the simple method that by just checking the angle, by just checking the theta, you can easily check that what is the speed. So remember, here we have taken speed or velocity because eventually the magnitude of velocity is anyways it is speed, right? So velocity is coming out to be 7/5, slope of distance time graph. Slope of distance time graph. So slope of distance time graph will give you speed. Okay. Slope of distance time graph will give you speed. So we have the coordinates. Then slope is coming out to be y2 minus y1 upon x2 minus x1, right? You must have studied this in maths class. So y2 minus y1 is, now if you want to check, okay, if you want to check, here, take a look. Here you are given with x2 comma y2, right? This is how we represent x2 comma y2, and this is how we represent x1 comma y1. So slope is y2 minus y1 upon x2 minus x1. Slope is what? x2, y2 minus y1 upon x2 minus x1. So y2 is what? 14, right? y1 is what? 7. So 14 minus 7, eventually you'll get 7 only here, right? And 10 minus 5 is again 5. So 7 by 5 is basically the speed which we have already discussed. Okay, so I hope there is no confusion in this topic, because velocity or the speed, because you know the magnitude of velocity is anyways it is speed, right? So slope of a distance time graph will give you velocity or speed. Clear? Now coming to the next topic, distance time graph for non-uniform motion. Now that graph which we discussed was for the uniform motion, and now what we're going to do is discuss for the non-uniform motion. Just check, at time t is equal to 0, distance traveled was 0 meter only, okay? But for time 2 seconds, look closely, then you will realize that the time interval are same, 2 to 4, 4 to 8, 2 to 4, 4 to 6, 6 to 8, 8 to 10, 10 to 12, 12 to 14. So we are talking about 2 seconds here, right? 2 seconds. The time here is 2 seconds. So in every 2 seconds, again we discuss about equal distance in equal interval of time. Remember, uniform motion and non-uniform motion. Just take a close look. Here the distances are not equal. Right? In first 2 seconds it traveled only 1 meter. So next 2 seconds it had to travel 2 meter, but it traveled how many distance? It was at 4 meter. So it traveled 3 meter distance, right? Definitely beta, definitely very soon will be coming, like I understood your thing, very soon will be coming with the 12th series, don't worry. So in fact what you can do is you can let me know the chapters also for the series that you are interested. We'll definitely make the series for that. Okay, so you let me know the chapters, in what chapters you are facing problem. Okay, so let me know the chapters in comment only, we'll discuss that. Right, so in 2 seconds it was 1 meter, then it was in another 2 seconds it was 3 meter, then 5 meter, then 7 meter, right? So these are not the equal distances. See, for every time interval the distance is increasing, so it will be like an increasing slope. Just take a look. Now on the x-axis I have time, on the y-axis we have distance. Okay, so 0 0 the first point, and then 2 comma 1. So at 2 seconds the distance was 1 meter, so it is coming 2 comma 1, right? So then we have 4 comma 4, then we have 6 comma 9, similarly 8 comma 16, 8 comma 16, 10 comma 25, and then we have 12 comma 36, then we have 14 comma 49. So if you take a close look now, for every coordinate the angle is increasing, right? For every coordinate the angle is increasing. So when you connect these points now, this will look like this, increasing slope, right? So it represents, like in the first graph, what did we understood? That the slope was constant here, right? So we said that slope is giving what? Speed. So speed is constant, but in this case, for every coordinate the slope is increasing, right? For every coordinate the slope is increasing. If the slope is increasing, that means, so I'll write that slope is increasing. And in distance time graph, what do we get from the slope of distance time graph? Speed. So eventually we can simply say that speed is also increasing. So slope of distance time graph gives you speed. Slope of distance time graph gives you speed. Hello. Okay, got your topics: electrostats, rotation, SHM, relative, fluid, solids. Okay, these are not 12th class topic. This is mixture of class 11th and 12th. Right, got it. So here slope is increasing. Slope is increasing. So for every coordinate, if you take a look, theta is also increasing. Right? For every coordinate with increasing time, theta is also increasing. Therefore, tan theta is increasing. Therefore, tan theta is basically the slope of distance time graph, and slope of distance time graph will give you speed, and hence speed is increasing. Therefore, it is a non-uniform motion. Got my point? So you just have to check the angle. Once you have the idea of the angle, this graph becomes very easy. Okay, so just check for the angle, and then eventually you'll be able to tell whether the motion is uniform or non-uniform. And also remember that slope of distance time graph will give you speed. Okay, are we clear with this? Coming to the next topic. Velocity time graph for uniform motion. Now, one thing I want to tell before velocity time graph gives you the maximum information. See, whenever we are discussing about motion, motion has limited parameters, right, that we completely study in this chapter. One is the discussion about the velocity. Other is discussion about the acceleration, right? And obviously distance and displacement. Now in motion, these physical quantities or these parameters are always taken with respect to time, right? So we have equations of motion to explain this, right? So whenever it comes to the graph part, in graph part, velocity time graph gives you the maximum information. Like with the help of velocity time graph, you can find out you can gather the information for acceleration. For velocity time graph, you can find out the information about the displacement and distance, right? And anyways, it is velocity time graph, so you will be getting the information about velocity. So you are getting all the parameters just by discussing one graph, that is velocity time graph. So even if, like you have studied the whole chapter, but I would strongly suggest that the key focus should be on the velocity time graph. Okay, whenever you are studying graph, discuss all the types of, or just go through all the types of velocity time graph, right? So let's discuss on that. Velocity time graph for uniform motion. Now think, on the x-axis we have time. On the y-axis we have velocity. So suppose, just for once, think that if it is a uniform motion, it is a uniform motion. If it is a uniform motion, that means velocity is not changing with respect to time. If it is a uniform motion, I am writing velocity is not changing, or I can simply say that velocity is constant, right? And that is happening with respect to, WRT means with respect to time. Okay, so for uniform motion, the slope will be 0 and we'll get the straight line here. Just take a look. I have made this 1, 2, 3, 4, 5, 6. This represents the time, and 10, 20, 30, 40, 50, 60. So if I'm moving with a uniform motion, right? So this boy is moving exactly with 50 meter per second. Its velocity is 50 meter per second. So with time, it will move with 50 meter per second. Its velocity won't change. If its velocity is not changing from point A to B, that means you won't get any slope. Here slope is 0. Why slope is 0? Just check for the angle. Is this line making any angle with the x-axis? We always make an angle with the x-axis. No, for slope we check that what is the angle it is making with the x-axis. So this line is making some angle with the x-axis, but this line is exactly parallel to the x-axis. And when it is parallel to the x-axis, theta becomes 0. And if theta becomes 0, there is no slope, then slope is 0, right? Because velocity, slope of velocity time graph. Slope of velocity time graph. So you can again just check slope. You can write down y2 minus y1 upon x2 minus x1, right? And what do you think? What do we have in y1 and y2? We have velocity here. And in x2 and x1, what do we have? We have time here, right? Velocity upon time, what do we get? Like if we divide velocity with time, what do we get? We get acceleration, right? So slope of velocity time graph will give you acceleration. Just like the distance time graph was giving you what? Speed. Okay, distance time graph. Okay, so slope of velocity time graph will give you acceleration. Slope of velocity time graph will give you acceleration. Similarly, remember the slope of distance time graph gave you the speed or velocity. So first thing that you need to remember is that slope of velocity time graph. Slope of velocity time graph is giving you what? Acceleration. Here, let's come back to this. What do we see here on the board? Uniform motion. If I'm saying uniform motion, that means velocity is constant. That means velocity is not changing over time. And if velocity is not changing over time, that means acceleration is 0. And if acceleration is 0, slope is also 0. Just cross check whether the slope is 0 or not. So angle is 0, slope is 0, that means velocity is constant. That means this is the graph of velocity time having uniform motion. Are we clear with this? So 2-3 things you need to remember for velocity time graph, that if there is no slope for velocity time graph, that means acceleration is 0. Okay, if acceleration is 0, that means velocity is not changing over time. If velocity is not changing over time, we call it as uniform motion. Clear? Okay. Right? So this is all about this only which I have covered. You need not to worry. Coming to the next part. See, this is another stimulation which I already told you that it is going from A to B, B to C, similar things. So in this graph also you will realize that other than acceleration, we can also find out one more thing. Now I'll tell you this mathematically first. What do we write velocity? Velocity is basically displacement upon time, right? What do we write velocity? It is displacement upon time. Now if you take a close look, this is the rectangle that we are getting here, right? In which if you try to find out the area of this rectangle, okay, so area is basically what? Length into breadth. Area is length into breadth, right? So think, for the length, like this we are considering as length, okay, and this is breadth. So length is basically the time, and time here is 3 seconds to 6 seconds. Okay, so length becomes 3. Okay, 3 to 6, so 3. And what about the breadth? It is coming constant, 50. Getting my point? Breadth is constant here, 50, and time is here 3. So if you try to find out the area, it will be what? 50, that is 50 will be the breadth, into 3, that is 150. 150 is the area of rectangle. Now, if you take a close look on this formula, velocity is equal to displacement upon time, right? And what exactly are we getting if we multiply velocity with time? Displacement. So velocity into time, velocity into time is what? Displacement. Velocity into time is what? Displacement. So now if we compare these two things, area covered under velocity time graph, area covered under velocity, area covered under velocity time graph. So in area covered under velocity time graph, we'll get what? Displacement. By just this simple rule that area is equal to length into breadth, right? So length we have the time and breadth we have, the distance 50 meter. Okay. So area of a rectangle is taken equivalent to the area covered under velocity time graph. So remember, area covered under velocity time graph will give you what? Displacement. When I told you that you can get two things. First, obviously, when we are drawing the velocity time graph, we have velocity and time. But what two parameters that we can get is the displacement and acceleration. So you need to remember this, that slope of the velocity time graph will give you acceleration. If slope is 0, obviously velocity is constant, or we can say it is in the body is in uniform motion. But there is one other thing that we get is the displacement, right? Area covered under velocity time graph will give you displacement. So remember this statement. You need to remember that area covered under, you can write it down. Area covered under velocity time graph gives you displacement. Slope of velocity time graph gives you acceleration. So remember, for velocity time graph, we can discuss about all the four quantities, all the four physical quantities, all the parameters that are involved in motion. Okay. So this velocity time graph, either we talk about the uniform motion or non-uniform motion, is very important. Again, I am repeating, slope of velocity time graph will give you acceleration. Area covered under velocity time graph will give you what? Velocity, displacement. Okay. Are we clear? Now, velocity time graph for uniformly accelerated motion. This is very important. If the body is uniformly accelerated, that means at every time interval, its velocity gonna change. Okay. Let's check this graph. So remember, this is the most important, and here you will get the maximum information, because in the last graph, the acceleration was 0, right? So you could only find out the displacement covered. But in this graph, you definitely gonna find acceleration and displacement. Okay. So changes in the velocity of a car at a regular interval of time are given in the table. Okay, so we are given the table. At 0 second, the velocity was 0. At 5 second, the velocity was 8 meter per second. Sorry. For another 5 second, velocity was 8 meter per second again. Like it increased. This is the change, okay? This is the change. We can say delta V. If you again check, change is constant 8 meter per second, right? Change, delta V. So with every 5 second, if you take a close look, that for every 5 second, velocity is increasing by 8 meter per second. This is the most important thing that you need to understand from this table, that it's not the velocity, okay, but in every time interval it is the change in velocity. That, like suppose, think for once, 0 second it was 0 meter per second, okay, for 5 second it was 8 meter per second. So when we talk about 0 to 5 second, its velocity increased from 0 meter per second to 8 meter per second. So it's a change, no? Again, it's a change. Take a close look. Change. How much velocity has increased? or how much velocity it has changed? 8 meter per second. Okay, now if I take 5 second to 10 second, like interval from 5 second to 10 second, then I'll again see the change from 8 meter per second to 16 meter per second. Getting my point? We are actually visiting the change here. Then we go from 10 seconds to 15 seconds and again see the change. 16 meter per second to 24 meter per second. 15 to 20, again the change. But if you take a very close look, you will realize that for every 5 seconds, velocity is increasing. Okay? For every 5 seconds, velocity is increasing. Now, your mind should work accordingly. Okay, velocity is increasing. Is velocity increasing at the same rate or it is varying with time? No, it is increasing at the same rate. That means change in velocity is happening at a uniform rate. Change in velocity, not velocity. Change in velocity is happening at a uniform rate. That means at the same rate it is changing. Now you already know that at every 5 seconds its velocity is changing by 8 meter per second. So the unit change in the velocity is same. Okay, and if velocity is changing at a uniform rate, we call it as accelerated motion. But here the acceleration is same, acceleration is constant. Now you have to realize the difference. Change is constant with time. Change is constant with time. So if change which is happening in the velocity is constant, that means same type of change is occurring. So if same type of change is occurring, that means the acceleration is constant because velocity is increasing, no? And velocity, change in velocity per time was acceleration. Remember? So if change is happening at a constant rate, that means we are getting some physical quantity called acceleration, and acceleration here is uniform. Okay, if the change is not happening at a uniform rate, then we can simply say that okay, non-uniform acceleration. But in this case, it is happening at a uniform rate. We have to, the numbers give you the exact idea that what is happening with the, with the particle or the body which is in motion. So you need to take a very close look on the numbers. This will help you out by solving the numericals and even, when you are solving the graphical method questions. So remember, just watch the numericals. Just watch the numbers, that what change, is there any change happening? Is the number constant? So whatever the data you have, that depending on that you can see. Okay, but remember this trick, find the change in the number. Once you are habitual to that, question done. Whatever kind of level that you are getting in the question, it will be easy for you only. All the questions are easy just because we have understood this concept that we need to see the change which is happening. You need to realize the change. Okay, so here velocity is changing. There is a change in the velocity and velocity is changing at a uniform rate. Okay, so when velocity is changing at a uniform rate, that means we have the acceleration, right? So that is why we have written uniformly accelerated motion. Acceleration is there because velocity is changing, right? Okay, now let's proceed with this. So again, we have time on the x-axis and velocity on the y-axis. I have plotted this graph for you guys. Okay, so again this graph is coming a straight line. If you join these points like this, it is coming in the straight line. So again, take a close look. Here the theta is not changing for any coordinate. For every coordinate, theta is same. That means tan theta is same. See, tan theta is applicable for distance time graph, displacement time graph, velocity time graph. So you need to remember this tan theta thing. Okay. So if you take a close look, theta is constant here, theta is not changing, and you are anyways getting a straight line or a linear graph here, right? So if you are getting a straight line, that means you definitely have a slope here, right? You definitely have a slope. How do we define slope? So here slope is again perpendicular by base. I mean the tan theta is perpendicular by base, right? So what do we have in the perpendicular here? Perpendicular is basically change in velocity, right? In perpendicular we have change in velocity. So if even if I take for some time interval, like suppose I am observing the object or the particle which is in motion from 10 seconds to 25 seconds. So at 10 seconds, the velocity was 16 meter per second. So consider this as initial velocity. This is initial velocity. Okay. Consider this as initial velocity. And again the other time interval which I am seeing is the final velocity. That is for 25 seconds, right? For 25 seconds, I have velocity 40 meter per second. So, y2 minus y1 upon x2 minus x1, this you already remember, right? So, y2 is here 40. 40 minus you have here is 16, right? Check out the time interval here, 25. And here you have 10. So 40 minus 16 and 25 minus 10, right? This is how you will get the acceleration. 40 minus 16 is how much? 24, and this is 15. So you are getting 24 by 15. Okay. If you check for some other time interval, okay, let's check. Now I'll take this, say 15 seconds, or let me take for 20 seconds. Let's do it for 20 and 35. Okay. So for 20, I'll have 32, and for 35, I'll have 56. So again, y2 minus y1 upon x2 minus x1, right? And y2 is here 56. So 56 minus how much? 32. Okay, 56 minus 32. For the time, 20 and 35. So 35 will be x2 minus 20. If you solve this, you will again get 24 by 15. So for every time interval, if you try to solve, you will get 24 by 15 only. So this is the slope, and slope of velocity time graph gives you acceleration. So this is the acceleration of the particle, that is 24 by 15. Are we clear with this? So I told you two things in this velocity time graph. One, the slope of velocity time graph will give you acceleration, and if the slope is, it's a straight line, it is not varying, like its angle is not varying with time. It is varying, but its angle is not varying. So if you get a linear graph, slope is constant, and if slope is constant, acceleration is constant here, which I have obviously I have solved it. Okay. So for acceleration, we are getting the value is 24 by 15. Got my point? Right? Yes, definitely we can draw the graph for non-uniform acceleration also. We're going to discuss that also, but I need you this to remember that slope of velocity time graph will give you acceleration, and here acceleration is constant. Okay. Coming to the next part. Now, if you try to find out the area, right? Initially, obviously we have from the last graph, we have learned that if you try to find out the area of velocity time graph will give you displacement. So similarly, if I try to find out the area of this, it will again give me the displacement only, right? Because we have studied already that area covered under velocity time graph. Area covered under velocity time graph will give you displacement. So now, let's find out distance, and the magnitude of displacement is anyways distance, right? So let's find out the distance traveled from 10 seconds to 20 seconds. So I need exactly this distance. I need the distance from 10 seconds to 20 seconds. So I need to find out this area, just this one, because I could have used for 0 to 20, but for now let's solve it from 10 second to 20 second. So I just need to find out this area, right? So what I can do is, I have two methods for this. Like this is a trapezium, so you can directly write down the area for the trapezium, or you can also do one thing for the beginning, like you can break this into two parts, simple, right? So this is 16, so this becomes 16 as well, okay, and the time interval is 10 seconds. So what you can do is, you can find out the area of the triangle, that is half base into height, plus the area of rectangle, so you'll get the total area. So either, this is the one method, first method, that either you solve for rectangle plus triangle, okay. Other method is that you simply solve for area of trapezium, right? Half, sum of parallel sides into height, okay. So sum of parallel sides, this will be the parallel sides that we were talking about. If we talk about the area of trapezium, sum of parallel sides, and this becomes height, okay. So half into sum of parallel sides into height. Are we clear with this? So there are two methods, but I would suggest that if the area of trapezium, finding out the area of trapezium looks easier to you, you can go with that. But if like you face some problem, because initially I know at 9th level, like we are not very used to finding out the area of trapezium, okay. So I would suggest that you should go with the area of triangle plus area of rectangle. That would be lengthy, but at least your answer will be correct. So eventually what I suggest you, that you go with this method and then you start practicing for the area of trapezium, and once you are used to it, then you can find it any way you want, okay. Right. So simply distance traveled is area of the rectangle, right, and the area of the triangle, okay. Area, how do we find area of the triangle? Area of triangle is basically half base into height. So this is the height and this is the base, okay. So length into breadth plus half base into height. This is the formula for rectangle and triangle respectively. So length into breadth, see height, breadth I told you 16, and the length is 10. So 16 into 10 plus this half. Breadth is again taken what? 10, and height is taken, see, take a look. This is 32, this is 16, so this height is also 16, right? So half into 10 into 16, okay. So 16 into 10, this becomes 160. 160 plus 80, because this is also 160, and into half. So 160 plus 80 is how much? 240. So I was simply able to find out the distance traveled between D and C. Here I specifically took out for D and C, but if you want, you can also find from, consider this point as A. So you can also find from A to C, okay, or any other time interval you want to find out, you can definitely go through it. But the only method that we have is that you just find out the area, okay. Is it clear? So what exactly did we discuss today was more of a distance time graph, displacement time graph, and velocity time graph. Remember that in velocity time graph, you get two things. One is the acceleration and other is the displacement. And for distance time graph, what exactly does we get from the slope of a distance time graph? We get speed, okay. And also there are certain things which eventually will be bringing up, like we have so many plans, but like the demand is very high. Like some students are asking for class 11, some students are asking for class 12, some are asking for NEET PYQ, some are asking for JEE PYQ. I assure you guys that we are working on it, and definitely you will see more lectures with time. I promise you that. But for now, like tomorrow I'll be having the lecture of class 11th. So those who are interested can come in that and they can learn from us. But yes, I would definitely go with the JEE PYQs, NEET PYQs, and specifically the 12th topics that I was given in the comment. I'll definitely look into that. So that's it for today. Thank you so much. See you again tomorrow, but the class will be different. It will be class 11th. Okay, bye bye.